Okay, so first thing, remember, guess on everything at Briarwood. Don't do that at State. At State, make it educated. I always have somebody who gives me this little history of probability, and they're like, Mr. Hurry, I mean, if I have 5 problems and I get one right, that's +5. Even if I miss the other 4, I'm sorry, it's plus, hold on, how do they do it at State? Well, Vestavia it is.
I think it's +5.
Anyway, bottom line is it's a wash. Like if for every 5 you get 1 out of every 5, you're basically yes. So at State, if you left 5 blank, you get 5 points. If you guess on all 5, you figure you're going to get 1 out of 5 and get 5 points. Here's the problem. How do you guess? Like, let's be honest. If you just close your eyes and randomly guess, then you're probably not going to defeat the laws of probability, right? You're just going to be a wash. It's going to be 0. So how do you guess? Like, think about it. What would you do on a problem you have no idea about? Okay, how would you eliminate? Do what? Well, if you knew that, it's not guessing, right? If you know something's not right, like if you know it's not A, because let's just say somebody asked for like, what is the distance between blah, 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 and you look down and you saw a negative number, and you're like, well, I know negatives aren't distances. Distances are positive. I can eliminate that. That's not guessing. That's using logic and reason and intelligence. And by the way, if you can eliminate an answer, the odds just tipped in your favor. Okay? You can eliminate 2 answers that you know. But let's be honest. If you don't know anything about the problem, do you know? So what do you end up doing? You end up just looking at it, right? And going, I kind of like this one. Let me be honest. If I'm making out a test, right, what am I going to try to do? Put out tantalizing looking answers that are going to get suckers to go, ooh, I bet it's this one. So literally your logic works against you. Now there was a guy at Hoover once who came up, it's really quite funny. He came up with this strategy for doing well guessing while knowing nothing. And he had gone through, like, I don't know why he just didn't study. Maybe he did. But he had gone through all these old tests and noticed patterns in the writing of these tests. And he came up with just like, and I looked at it and I tried it a couple of times and I'm like, wow, you can actually beat the laws of probability. And then it got around and teachers got wise to him. The people writing the test got wise to him and started, sabotaging his theories. But for a while, they was like, hey, if the question ever asks so-and-so is an answer, don't ever. But he had this little strategy and he would always beat the laws of probability. But the bottom line, unless you can't eliminate one logically, I don't mean that's not pretty, I'm eliminating it, because they're just falling into their prey. I mean, there was somebody once who made a -19 on a test. Do you know what you have to do to make a -19? You almost...
And not get them.
Yeah, do you know how hard it is to miss 19 questions out of 19? Like, that's difficult. Randomly guessing and missing all of them. You would almost have to know the answers and avoid them. Well, it's A. I'm not picking A. So literally, that happens to people. I had a guy once who came and made a 42 on a test, and I'm like, dude, you dominated this. I didn't want to say that's out of your character because he was a smart guy, but he normally didn't do that. 42, and I was like, what did you do? Did you just have a good test? It really fit? He goes, oh man, I guessed. I was like, dude, that doesn't always work out for you. You know that? He goes, oh, Mr. Hurry, you miss 100% of the shots you don't take. And I said, okay, that's great. Next test was the state tournament test. Well, no, it wasn't. Next test was the Hoover test. 6. Made a 6 with his guessing strategy. And he was a smart kid that could have helped us or whatever, but my thinking is the guessing is not going to help you, except at Briarwood, guess away, because you don't get penalized for missing or anything. So make sure you answer every question at Briarwood, but at the state, don't do that. Now, again, like I said, if you look at it and you're like, wait a minute, I know it's not this, or I know it's not that, and logically you know, not because it's not pretty, but you know, well, everyone you cancel out increases the loss of probability for you, so that it's not really guessing, it's intelligent selection. But if you're just like, I don't know the answer, whatever, it's not helping you, and you're probably going to get tricked out by the writer of the test because they are going to put out some succulent looking answers out there, and you're going to be like, yes, yes. And they do it every year. Okay. So with that being said, let's jump back into, also the Briarwood tournament, you should be in your room ready to go at 8:45 in the morning. Now know yourself. If you're like, well, if you tell me to be there at 8:30, I can be there on time. I don't know how many minutes it takes to get to Briarwood from Homewood. From my house, it's 10 minutes, but from out here, could be 15, could be 20. I don't know. It's a Saturday morning. There's probably not much traffic going out there, but check it. Like maybe get home tonight and somebody check, hey, at 8 o'clock, what's the traffic look like? Because it's probably died down or at 280 traffic. But it's a good jaunt out and don't go to the church. It's not, I know there is a school at the church, their elementary school, but Briarwood School is out there on Highway 119 or whatever they call it. There's a formal name for it, but it's just way down 280, hang a right, go down Highway 119 and it's on your left. Or if you're coming, like if you're closer to 65, like if your house is like West Homewood, then go down 65 till you hit 119, take a left, and you're going to go way down and it'll be eventually on your right. So whatever you do, figure out how long it takes there. But if you're there at 8:45, I'm good. But you should be in your room because they get everybody organized, they get them in their room, and then they start testing right at 9. Are you with me? And you're going to take the written and the ciphering. So if you're there, you'll take the written first. They'll have a break. They usually just bombard you with donuts and whatever. It's not like crackers and water like they do at other places. They usually have pretty good. Y'all didn't go last year. They didn't have it last year, but they usually have like 10,000 boxes of Krispy Kreme or whatever. I mean, really. I mean, people are coming out of there like in sugar comas with crumbs on their face, and they usually have a ton. So they'll do that, and then, which I don't know what they'll do now because it's post-COVID, but I'm assuming they'll still have that. Well, it's not post-COVID, but it's like in the new era of COVID. So I don't know what they'll do, but then then you'll take the ciphering at like 10:30, but that doesn't take a whole hour. So you should be done a little early, you guys. And so if you have to be somewhere, I know there, maybe not in this class, but there are a couple people that have to zip out. Like I said before, if they're like, no, we can't release you till 11:30, just go up there and ask them. Or if you remind me Saturday, I'll go up and say, hey, I got a couple guys that got to be at show choir thing. Can they slide out the back? They're good about that. If not, again, make a run for it. You'll be all right. All right. So, but at the latest, it's 11:30. Like Helmer's group will start testing at 10:30. They'll be done at 11:30 sharp. So, and then that should leave you plenty of time, 30 minutes to get back. It's not like Christmas holidays or anything, so the traffic should be fine. Might take you a little bit longer, but not as long. All right. Also, I need to know if you have an issue going to the state tournament. I have to register on that by Friday, the 28th, which is only a few days. So the state tournament is on February 26th. I know right now that there's a show choir conflict. I know right now that there is some kind of swimming conflict. I know right now that there's a JV soccer conflict, but I think that doesn't start till 11:45 or 12. And we should be done at 11. But here's the flexibility we have for the state. For the state, it's going to be here in the high school again. What they said is it has to be completed in a 2-hour window between Friday the 25th and Sunday the 27th. But I can't test you at different times. So I can't let like half of you do it on Friday because you have a Saturday conflict and the other half on Saturday. Now what they did, and some of you might have been a part of this, I know one of the Jacksons in the other class was last year, and I think there were some others also. Helmer's let you come in early at like, maybe it was like 7:30 or something, and tested you till 9:30. And then we started the other group at 9 and went to 11. So there's a chance we could work that out again. If they let us do it again, I don't see why they wouldn't. But, and that as long, they're just worried about you communicating. But if you were still testing when they started, there's no overlap, there's no communication issue. So that might work. But I need you to check quickly and find your conflicts. And again, I want to be smart about these. I didn't care if y'all missed. I mean, I was curious as to why you were going to miss Briarwood, and I wanted to know that and get it written down. But I'm not quibbling about that. But typically, we care. Like it's part of this class. It's like if you have football and you're playing football, you're supposed to go to the football games. You can't just say, well, I'm not playing, I'm out, or I stink, I'm out. I mean, that's part of the obligation of this class, and especially at our state tournament where it matters. And I know that somebody says, well, my score never matters. I had What's Will Stone's sister? Who knows the Stones? Was it Mary? Claire? Doesn't sound right. Is it a double name? She was like, I want to go to this concert. I'm like, I can't really excuse that. That's not fair for everybody else. They're giving up stuff. You can't do it. So she went to her concert Friday night, got done at 11, drove back from Atlanta. She was like, my score never counts. She came in fourth. So it did count. So it helped us and improved our, so you never know. You might have a good day, you might have a bad day. I mean, sometimes your best student doesn't do well. Sometimes your best student does super well. Sometimes the student that normally doesn't well does better. So I want everybody there. If you have a conflict though, I want to use good common sense about it. Like I said before, I mean, obviously I want my people that if you were like in the top 10 last year or top 15, or you were a stud, and even if you stunk at geometry, if you were a stud in Algebra 1 for Miss Tyree, I would love for you guys to be there. I mean, I really want you guys to be there. If you're a soloist for the show choir, I'm sure he really wants you to be there. So I want to use good common sense and make it a win for our school, not just a win for show choir, just a win for me. So, but I need to know that quickly. The best way you could tell me is to email me. And then if I'm okay with it, whatever, if I'm not, we'll have a conversation. But every year we have a conflict with show choir. And every year, depending on the group you're with, it is possible to do both. So usually it's Briarwood, where we have like a minivan pulls up and 7 people with boothy hair hop in the minivan right after the tournament, and they drive to Auburn, or they drive to Muscle Shoals, and they drive to Mississippi or whatever, and they make it there in a couple hours, and they're able to still compete while still competing for us. That happens all the time. Now, if we're competing at the same time, can't happen. But it's possible that it can for state, because we have that flexibility to start you early. And I think your conflict is in Auburn. Am I right? So it's 2 hours and maybe 15 minutes from Auburn. So like if you were competing at 1 o'clock, it's totally possible to get you out of here at 9:30 and you're there at noon and you still have an hour. If you're competing at 10, I don't see how that's going to happen. So we're going to have to figure something out, right? Are you with me? So again, I like common sense. I don't just like, here, this is the way we do things. I like to think about it and use good judgment. But I need to know that as quick as possible. So any other conflicts I might not know about, baseball, soccer, whatever, let me know, and we'll try to make the best of that. But I hate to overpay, right? I hate to pay for stuff and then somebody doesn't go. It's just wasting your parents' taxpayers' dollars and our community's money. So I really want to know to the best of your ability right now so that we can figure that out. All right, so let's jump to any questions on anything? You good? Okay, let's jump to the rest of these conic sections and let's talk about what all these formulas mean. I mean, all these little variables mean. Did anybody have any questions on the homework? Did you find yourself thinking to yourself at all, man, which one is A? You didn't, did you? You don't need A. Which one's A? Which one's B to graph it? You don't. You just need to know number under the X, square root it, that moves X ways. Number under the Y, square root it, that moves this way. And then that's an ellipse, and then that gives you the framework for everything else. But you didn't really need to know, didn't want that. You didn't really need to know A or B to do that. So here's what you do need to know, and we're going to start with ellipses. Now, when you go, come on. When you go to, man, this computer and everything is just so bad today. The spinning dial of doom here. Okay, so going back to ellipse notes. So here's what we know so far. We know how to sketch these. We also know how to find the center. We do know that on an ellipse, of the two numbers, whichever one on the bottom is bigger represents the A squared. We do know that. And then, and we know the length of the major is 2A, length of the minor is 2B. Okay. Do you remember me mentioning eccentricity? We mentioned that the eccentricity is I actually looked this up the other day. It's really the measure of the circularity of something. Well, a circle has, or deviation from circularity. So a circle is a circle. it is not deviating from a circle at all, so it's a 1. I mean, it's a 0. So there's 0 deviation from a circle on a circle. That kind of makes sense. A parabola, for whatever reason, supposedly has a deviation of a perfect 1. And I think this has a lot to do with the slice. So the deviation on the slice, if that's a 0 through the cone, right? If that's a 0 right there for the circle, then the ellipse is going to range from a 0, right? The ellipse is going to range from a slice of a 0 to a slice that actually is parallel to the side, which we call a 1. So a parabola has a 1. So from 0 circle, 1's parabola, everything in between that is a ellipse. So the eccentricity on an ellipse ranges from 0 to 1. The closer it is to 1, the skinnier, more elongated that ellipse becomes, right? Because if I tilt it just a little bit, you probably aren't even going to notice it's not a circle. It's going to be very close. But the further away from that right there, the further away, the longer the cut becomes, the more skinny and oval. So the closer it becomes a 1 until it becomes a 1. And then bigger than 1, that's where it just continues to change the angle of the slice and then starts hitting both cones. Those are hyperbolas. And that slice right there could actually go to infinity. But the nice thing about that is you can memorize the eccentricity of an ellipse is 0. You can memorize the eccentricity of a parabola is 1. And then the other 2 eccentricities you can find, everybody with me? By just going C over A. So the eccentricity is C over A. Now you're like, what the heck is C? That's what we need to talk about today. So it's going to be hard for me to do this on this board, but I'm going to try, and it's going to gum it all up, but we're going to do it anyway. So this is how would you do the eccentricity of an ellipse? How much ever do this? Okay, so an ellipse, okay, so first of all, this would be a circle. If I stuck this to a board, hold on. Come on. Oh, this is freaking it out right here. Sorry. All right. I'll beat the system here. Okay, so pretend this is my center, right? If that's the center, then this would represent the what? I know it's gonna be terrible. This represents the what? The radius. And clearly, minus all the extra little dots, I could, good gracious, I could bring this around and make a circle, couldn't I? Give me that, right? Okay, so, I can beat the system. You are not going to beat me here. How about this? I'm trying to do, but if I do white, I can't draw it. I actually did think that for a second though. Shut up. But that makes sense, right? If you have a fixed length, a radius, and you rotate it around, you get a circle. Well, what happens with an ellipse? The center splits. I mean, there's still going to be a center, but it like splits into 2 foci. Okay? So as it splits, and again, this is going to be a mess. Here we go. As it splits into these 2 foci, all of a sudden, you don't have 1 radius anymore, do you? Now, we still are going to have what we call the center. The center is somewhere in here. And it does not want to behave. Work with me. I would do it here, but Mika can't see it at home. And she's on my thing. Right here, and I may just have to do that, and maybe I'll tilt it or something. You know what? Let's just do that. All right. No, it's all right. Okay, you can kind of see it. So say, all right, so I'm splitting. There's still my center right here, but I'm moving these things apart. And the more I move them, you're going to see the more I move that foci out, the skinnier this thing gets. Okay, it's kind of like changing my slice on the cone. right? So these become, from one center, they split out and you have a focus here and a focus here. And plural of focus is that, and it's foci if you're Latin, but I hear people say foci all the time. So whatever, I don't care. But that's the plural of those. But there are two of them, okay? Now, on this focus, you no longer have a radius. You have what you call a sum of focal radii. So the sum of focal radii is basically the length of my string. So what happens is on a hyperbola, I don't know why I said hyperbola. On your ellipse, okay?
Make a perfect circle.
On an ellipse, it comes because what happened to the length of my string here? It never changed. So this little focus, focal radii, and that focal radii are different. These two are different. These two are different. These two are different. But the sum of them is the same. So that's literally the definition. The definition is all points in a plane. I'm not going to make you know this, but all points in a plane whose sum of focal radii is constant. Okay? Whose sum of focal radii from two fixed points called foci are constant. That's what it is. So the bottom line is, how can I make sense of this with my A and B? Well, you already know that when you are sketching this, you went left and right to get to your vertex if it was stretched more this way, right? And what was that amount that you went there and there? It was the amount below the x, right? But if the amount was bigger this way, that distance was what? A. So you already know that from the center, not to the focus, but all the way there, that distance is A. And all the way out to this vertex, that distance is also A. You know that already, right? And then you know that the other value, if it was smaller, say it was below the y, like it is in this case, that was your B, and that's how much you went up, and that's how much you went down, correct? That was B. Now, let's look at the length of this string a little closer. If I took this string, whatever the length is, and brought it to right there, are you with me? What would that mean if I cut this little part out and put it over here? So the length of my string is also 2A. So the length of my, does that make sense?
Yeah.
So the length of my string, which is the sum of focal radii, is 2A. And the nice thing is on a hyperbola, there's not a sum of focal radii. There's a difference of focal radii, but it's also 2A. So that's great. But what this means is the length of the string, which we call the sum of the focal radii, radius, focal radius, they're always equal to something. And that something, think about it, it goes from here to the vertex and then back. If I cut that little back there is the same as that right there, which means the length of my string is the length of the major axis, which is 2A. Now, what would it mean if I did this and brought it straight up? What does that also mean? If the length is 2A and I brought it straight up, what does that also mean?
Each one is A.
That length right there is A, and that length right there is A, right? Well, if that's A and that's B, and this is a right angle, couldn't I find this mystery side using the Pythagorean theorem? And isn't that mystery side the same as that one? Now, what do you think I want to call the distance from the HK to the focus? Why not just call it C? Because that's what I did with the vertex. From the HK, which was the vertex. That's what I did with the parabola. On a parabola, the distance from the HK to the focus was C. Let's just call it C again. Now, what's the relation? This is why you got to know A and B. So if I know A and B, I can plug them into my Pythagorean theorem. Now, don't memorize the Pythagorean theorem wrong. Normally, you learned it to be C squared equals A squared plus B squared, right? But what is it this time?
B squared.
It's A squared equals B squared plus C squared. Now, I have it written down differently, on your notes, and I'll go back and show you this. What I do, and it's a little trick to help you memorize this, because that little formula doesn't work on hyperbola. But I'll show you a way to kind of link them together and help it make sense. Isn't c squared equal to a squared minus b squared then? If I move the b squared over? So here's what I do. This ellipse right here would have been kind of like this form right here. I just happen to move more along the x, so that's the a. All right, sorry about this. I happen to move more along the x, but to find c without drawing this crazy picture, all I got to do is look at these two numbers, take the big one, change the sign, take the small one. Big one minus small one. So basically, if I want c squared, I take big, I just change the sign of that and go big minus small. On a hyperbola, you'll find, to find c squared, all I got to do is take both of them and change the sign from a negative to a positive. So the rule ends up being kind of the same. To get c squared, take your a squared and your b squared and subtract them when it's positive and add them when it's negative. And it makes it nice and neat, and you don't have to think about your picture anymore. So going back to this, like right here on this example, where is it? See that example on your ellipse notes? Oh. Man, it'd be great to be like 5'11". Ah, nice. So right here, look how easy it is just to find your c squared. If I'm looking for c so that I can answer some of these other questions, I go, oh, well, c squared is big one, change the sign, small one. So my c squared is 9, c is 3. So now when I go, what's the eccentricity? If the eccentricity is c over a, I take my c, which is 3. What is a? The biggest of those two when you square root it, 5. So my e is 0.6. And like we said, isn't an eccentricity of an ellipse between the 0 and the 1? There it is, 0.6. Now, a couple other things. How do you find the area of a circle? Pi r squared. I showed some of you this maybe yesterday. Why? Well, remember, a circle is like an ellipse. So technically, except it's a special one, technically, the area of an ellipse is pi times a times b. The area of ellipse, pi ab. Well, if you think about it, if you have a circle, those two things match. They're not a and b, they're r and r. But it's still pi times r times r. It just ends up being pi r squared for a circle. But for an ellipse, when they're different, pi ab. That's your area of an ellipse. There is no area of a hyperbola because it's not enclosed. Okay? So that gets you to c over a is your eccentricity up here, and pi ab is your area. We talked about sum of focal radii. It's always 2a, like we mentioned up there. That gives you that. And these are questions I'll ask on a test, I guarantee. And then you already know about length of the major and the minor. Now you know what c is. It's the distance from the center, the hk, out to each focus. We call that c. You can see it there and there. I also labeled it on your notes on one of these. There's your C, center to the focus. There's your B, center to the, whatever that point is that's along the minor axis. And there's your A, center to the vertex along the major axis. And then the last couple things here that we haven't quite talked about yet is the length of the lattice rectum. Now, do you remember what a lattice rectum was on a parabola? What is it? Describe it to me. The length or the width between the two arms of the parabola going through the focus. Let me show you something. Isn't an ellipse? It's not. But doesn't it kind of look like a parabola going that way with a focus right there? And doesn't this one kind of look like a parabola going? Now, it does not have parabolic properties. It's not a parabola. But it kind of resembles two parabolas kind of heading together with a focus, right? Well, it turns out that is a lattice rectum going through the focus. And that is a lattice rectum. But it's found completely differently. It doesn't have any relationship to C like you knew to flip it or whatever with A. It has a separate value. And I figured this out. You don't see this in books, but I started doing these. And I'm like, it's so hard. This is how I used to find it and tell my kids to find it. Okay, guys, you got to find the focus. And they're like, we got it. All right, I said, take the x coordinate of the focus and plug it into your formula. So they would find that x coordinate, say it was, in this case, 0, over here it's 6. They would come in here and they would plug 6 into there for x and solve for y. And in the process of solving for y, y'all with me? In the process of solving for y, they're going to square root and they get 2 answers. So they would get the 2 answers and they would know these 2 y values. They would know the y values say here and then here. And then you know what they would do with the 2 y values? Subtract them to find the length. And that's how we used to find the length of the lattice rectum. So then I did it generically to try to see what happened. And guess what I ended up with? 2b squared over a. Done. So all you have to do to find that length, all you have to do, and I put the formula right there, length of lattice rectum, is 2b squared over a. So if you know the formula, there's the b squared. So 2 times 16. The a is the 5. So divide it by 5. So I get 32 fifths. And 32 fifths is about what? 6-ish? Right? So if you wanted 4 extra points, look what you can do. You can go to the focus right here and say, well, if the lattice rectum is 6-ish, I can go up about 3-ish, down about 3-ish, go to this focus and go up about 3-ish, down about 3-ish. And if I have those 4 points along with the up, down, left, right of the A and B, now I've got 8 points to sketch my parabola, which makes it an even better looking sketch. I don't even have to use parabolas that way. I mean, a little parentheses that way. It just gives me a bunch of extra points. Now, I don't need you to mark those, but I do need you to know the length of each lattice rectum. So it's really easy, 2b squared over a. It's also easy not to learn that formula and miss 3 or 4 points on your test. So don't do that. Anything else I'm missing? Directrices I may come back to. Area, eccentricity, length. Okay, so, and the only other thing is completing the square. Now, on a parabola, when we completed the square, we only had 1 squared term, didn't we? And we wanted that on the right. Well, on an ellipse and a hyperbola, we have 2 squared terms on the left. So the only thing I want to move over is what? The constant. I want to get my x's and y's together. Sadly, I can't divide by the lead term because they're 2 different lead terms. It's not going to help me. So I factor out a 16, factor out a 25. I complete the square. But when I complete the square and put 9 and 4 in there, what did I really add? 16 times 9. What did I really add? 25 times 4. And then you get to here. And at this point, what's wrong with this form? What's it supposed to be equal to? 1. So whatever that number is, divide by it. And when you divide by it, most of the time everything cancels and you get a nice, neat, clean result. When it doesn't cancel, I mean, it does cancel. It just might give you a decimal or a weird fraction. Like, what would happen if that 16 was not there and there was a, I'll tell you what, I'll give you a better looking one. Here's a very simple looking, what if you had a 12 there and a 15 there, right? You got a plus, and it's equal to, let's just hypothetically say this thing is equal to 150, right? Hey, we'll make it easy. It's equal to 15. What would you do to make this a nice looking ellipse? Make that a 1. Now, what happens when I do that? There's my 1. Awesome. Here, everything cancels, and I get y squared over 1. Awesome. Here, 3 cancels, but I can't write 4x squared over 5. So what do I write? Yeah, if you do the math on it, you're really going 12 divided by 15 is 0.8. You can do that, but you want to know a really easy way to write 0.8? Take this 4. Actually, it's not that. What is it? It's 5/4. It's not 0.8. But right here, take this 4, swing it down. Because if you really think about it, aren't I taking that 15 and putting it below that and then saying that that's 1? Well, I take that 12, put it below that, cancel. I'm saying it's 5/4. Rarely does that happen, but you can't have anything left with the x and the y. So if this did not cancel completely and give me a whole number, if it doesn't, then just whatever you have left, swing it down underneath that. In this case, it's a 1, so it doesn't matter. But swing it down underneath, and you're done. That's everything you need to know about an ellipse. All right? Hyperbolas have subtle differences. Let me show you them. First, I'll show you all the similarities. First, they don't have a sum of focal radii. They have a difference, but beautifully, it's still 2a. They do still have length of lattice rectums. The length of each lattice rectum on this is still 2b squared over a, which is awesome. The eccentricity is still c over a, which is awesome, except it's not going to end up being 0 to 1. It's going to end up greater than 1. That's okay, right? And then the center, do you remember the trick I told you? Over here, not the center, the c value. The c value, do you remember I told you the trick was to say c squared equals what? Biggest, change the sign, smallest. Well, here, to find c squared, you can take biggest, smallest, doesn't matter. Biggest, change the sign, smallest. It really doesn't matter because you're adding them, does it? Whether you go small plus big or big plus small, you're still adding. But you can think the same way. Hey, c squared equals the biggest plus the smallest. Just change the sign, square root, whatever you get, you have your c. And your c helps you find your eccentricity. Your c can find some other things too. All right? So I did a little example here. And again, and the only extra thing you have to know about this is equations of asymptotes, which we talked about yesterday, right? But do I need to know c for that? Nope. I just need to know the rise, which might be a, might be b. I don't know which way it's going. I need to know the run, and I need to know the vertex, the center, which I have for my equation. So you can look at all these very similar kind of thinking on all these, but that's a directrix. Now, sadly, the directrix, I do not have a pretty diagram with string. It does have a situation I'll point out to you, though. Here is an example of this hyperbola. So there is no sum of focal radii. There's a difference. So this is what it means. The definition of an ellipse is all points whose sum of focal radii, or whose sum of the distances from two fixed points called foci, is the same. Sum of those radii. On a hyperbola, it's saying the difference of those radii. So think like this. If I took this focus and drew a straight line from here to the graph, that's a focal radii. And then if I went back from here to the other focus, that's a focal radii. If I subtract those two lengths, I still get 2a. The difference in those two lengths is the length of the transverse axis, which is 2a. And you can take a ruler out and check that if you want. There's a ruler. Let me show you. I'll blow it up and we'll look at it. Okay, so check it out. I'm going to pick this point right here. So I'm going to measure focus to there. Focus to there is, we got 20 and a half. Then I'm going to measure other point to other focus. What is that? Maybe 5.75. So if I subtract that, I get what? 14.75, roughly. That should be 2a. The difference of focal radii is 2a, and 2a is the length from vertex to vertex, right? So that should be about 14.75. What do you see? 14 and a half, 14.75. No matter what point I pick, no matter what I pick, if I measure that to that and that to that, those are focal radii. The difference in those two should always end up being 2a, vertex to vertex. But that's not fun like the string. And also, you're the first class that didn't make a comment about the string. I'm going to give you one more chance. Yes! Oh, you did? Okay. Every year, 29 years, as soon as I draw this, people go, oh, it looks like a smiley face. And I didn't hear anybody say it.
It's like a little graph.
Yeah. Yeah. So,
Yeah.
All right, good. But I didn't hear that. All right, so guys, that's it. If this, you're gonna find this test, if you can get it memorized, like I know there are people who go, I memorized great, but I just can't think through these really hard problems. This is your test. But there's also people that go, yeah, I do well because I can figure my way through this test. Can't figure your way through memorization. I don't know that you can. Now, if you remember the perfect setup and diagram, I guess you can rethink all that. But this test has a bunch of little simple answers. It might have a problem or two similar to homework problems that you have to work. Like there's a tunnel problem in here that we talked about, I think, once before with parabolas. It's an easier one to do with ellipses, but I think there's a tunnel problem in there. Those are the kinds of questions that might show up on a test in addition to facts and information. But the bottom line is you've got to know all of these things to get stuff done. And let me give you a quick example. So look right here. Oh. So let's just say, we've already done that. Let me just give you an example of, I'm going to save your review for you. What if, so what if I said this? Sum of focal radii is 12. Then I said this, then I said eccentricity is 0.6. All right. And then I said center is 2, -1. And the graph is stretched up and down. You should be able to come up with what kind of conic.
Oh,
How do you know it's an ellipse? The eccentricity is between 0 and 1. How else? Sum of focal radii, not difference. So you go, okay, well, crud, I don't know. It's x minus something. Well, x minus 2. And it's y plus 1. I know that. There's a plus, but I don't know what goes there, but I do know it's equal to 1. That's how I would start. And then I would do this. What variable does this give you? If that's 2a, I know a is 6. Okay, I got my a. I don't know which one it goes under. Oh, wait. Yeah, I do. If it's stretched more this way, then a is the biggest, right? So what does that tell me? That must be a 36. Now you're down to one variable. How are you going to get that? Wait, what's eccentricity defined as? C over A, but A is 6. So what is C? 3.6, right? Well, now I have A and C. Can I use A and C to find B? What's the relationship with an ellipse? C squared is always what? Biggest, change the sign, smallest, right? So if I know my my C is 3.6, couldn't I take 3.6 squared, right? And the 36 and solve for B? Can I? So I don't know what that is. B squared equals whatever 36 minus 3.6 squared is. And then once I don't even need to square root it. I want the B squared right there. I take this and I shove it right there. And I am gold. That's how well you got to know every little formula to be able to get some of the trickier ones on my test. But some of them are just simple answers like, what's the eccentricity? What's the sum of the focal radii? What's the this? What's the that? What's the A? What's the C? Guys, we got a 2-day review. Do the best you can on your homework. We're going to review all day tomorrow, all day Thursday for our test on Friday.
I'm not going to be here Friday.
I'll put it in the makeup bin and you make it up whenever the makeup testing days are coming. But no worries. Then it wouldn't be an ellipse. It would be a hyperbola. Yeah, it's never negative. So if it's 0, it's a circle. 0 to 1 ellipse. 1 it's a parabola. That's bigger than 1 a hyperbola.
Wait, what's this?
It's the same formula, but it should be.